morning, guys, and welcome to AI Governance Engineering with myself, Gavin. And today I'm just going to be talking about, quite loosely, talking about this sort of curriculum I've created for myself using Claude and then Cursor in combination. And the objective was, I think I want to focus more specifically on machine learning algorithms, things like that, using certain ISO standards as I keep, developing this interest in the data side of things. I feel like the machine learning area is something that I want to sort of drill into. So I had this idea to take all these standards, these ISO standards that relate to data, and package them into a course which can help teach me essentially how to audit AI algorithms. And again, I don't know if it's right or wrong, but I've kind of based it around the ISO standards and what would they be looking for in a algorithm audit. And obviously I can save myself a few $1,000s in purchasing any other sort of current offerings on the market. So I'll just give you like a brief overview of how I've built this. It's over 16 weeks, the course is. Again, it's my own course, it's not for sale or anything like that. Yeah, it's over 16 weeks and it's going to teach me a number of things. So as you can see here, what's it saying? There was a few errors at first. Claude made some errors with ISO 5338, which is the AI system lifecycle. And I was like, hold on a second, I'm sure that doesn't exist, because I was checking against the actual document and I couldn't see it in there. So if you're going to build a course like this, do be careful, because Claude makes errors, even though, as you can see, it's got all the files here in its sort of essentially its database. It still made mistakes. So you need to be careful about that, because that's a massive oversight, especially when you're, trying to build something within this particular industry. It's got to be correct. You're auditing. So I noticed that, and that's, I'll take that as part of the auditing process, a learning process, so to speak. So what I did to sort of vet that was take it into the whole sort of setup into Cursor instead, where it can scan the PDFs a bit more confidently. I can cross-reference all within the same IDE quite smoothly, and you can just get it to just keep checking and keep being more critical in its checks. So I'm confident now that it's where it needs to be. So I created stuff in here, first of all. And how this is going to work now is, you can see here it's got standards, EU AI Acts, ISO 19011 for auditing management systems, 5338 AI system lifecycle processes, ISO 22989, AI concepts and terminology, core AI governance 42001, 23894, 42005, data quality, probably my favorite part, 5259, 1, 2 and 4, specialized standards 24027, bias in AI systems 291192, 3 and 4 for software testing, and 25058 for product quality requirements and evaluation. So yeah, that's just a list of some of the standards in there. Yeah, it's saying it's going to be over 16 weeks. Take that with a pinch of salt. Obviously, I'm just trying to teach myself here how to get some understanding of auditing AI systems, algorithms, should I say. But it's quite well laid out. It knows what I'm using, what tools. And again, I'm not trying to be a data scientist. I'm trying to be an auditor. So it will be reminding me of this throughout. Not sure what these symbols mean. If anyone knows, please tell me. How to verify. And then we've got a week-by-week curriculum. So that goes on and on and on and on and on. Yeah, there's all kinds of details. So this is going to be just for mostly for the conversational side of things. If I need to have like a knowledge check or something like that, I'll jump into this project in Claude. But I feel like most of my work's going to be done inside the Cursor IDE. So if we just have a look through some of the files that we've created here, we've got the complete main file here, and then we've got a curriculum. Let's have a look. Knowledge base has got all of my documentation in, and some of the things where we had to do some validations, some restructuring, stuff like that, just to ensure the integrity. Enhancement reports. So the report summarizes extracted information from 421192. Recommendations for pattern enhancement include all shall requirements from all standards. What else? Pattern quality comparison or pattern enhancement complete as being comprehensively enhanced with detailed information extracted from all 12 ISO standards using specialist analysis agents. And we've updated the main file structure, the system.md, context.md, and readme file. So if anyone doesn't know what these are just sort of the brain of this program. So it's going to be, not straying so much. And that is the future of using AI tools. I think if you're using them aggressively, let's say, as people like I am, you soon begin to realize that you need a bit more consistency from them and not just this generalized output they give you. And that's where system and context files really kick in. So that's got this anyway. And this particular file is just showing you where it's enhanced my idea, my curriculum, compared to what we started with in Claude. Added mandatory requirements again for all these particular standards. And as you can see, these are like fresh standards. 42119 only came out this month. 25058, you don't see anyone talking about this quality evaluation. 5338, lifecycle requirements for AI systems. Again, why are people not talking about these things online? It's crazy. 5259, again, conversation is minimal, to put it lightly. And these form the backbone of good data in AI. So, what are we doing? Again, I just believe that for now, the gold rush is in sort of the ethics and bias talk at the moment, and everyone wants to just be on stage, getting their opinion across. But when it comes down to the engine and getting work done and, the deep work, let's say, this is to me where it lies, unless I'm completely wrong. Remembering again, I'm just learning as well. But from what I can see, I'm thinking, well, where's the conversation about this? It is minimal. So this side of things is not mature yet. This side excites me from a technical standpoint and a learning curve standpoint, because I'm not a machine learning engineer. I'm not a data scientist, but what I am is a keen learner, and I like to set myself, high targets to achieve. And if you just think about what we can do with these tools now, with a knowledge base, a system, and a context file, and all of the documentation you need, then what's stopping us, really? So that's the purpose of this tool and why I'm working through it. Sorry, that was a bit of a side rant there. So in here, I just wanted to make sure it was extracting as much as possible out of the documentation. So it's enhanced certain sections. At section 2, added mandatory requirements section, extended the risk-based testing with detailed 23894 processes. What else? Expanded quality evaluation with all 25058 characteristics. It's enhanced my context MD by nearly 500 lines. Detail requirements 29112 mandatory process. You can see you got 22 should requirements added. So yeah, this is just showing you, like, when I'm building this tool, this curriculum, I'm not just accepting what these tools give me, even a project inside Claude, because it's just not, it's not trustworthy. It was making errors from the start. But I've always had this mindset, because of what we're doing is serious and this has to be correct, that I've always tried to cross-reference it with the actual documents as much as possible. And again, just looking through here, just tons of enhancements. It's just really exciting that you can build out your own learning pathway like this, and especially in a side of AI governance and audit, which is still infantile, if that's a word. It's fresh out the womb, fresh out the oven. I mean, I've seen conversations going back 2-3 years about this, which is quite impressive. So those guys were super early to the conversation. People like Shay Brown from Babel and a few other guys. And I've recently just come across Rob van der Veer. So shout out to you as well, Rob, because again, 5338 he played a heavy hand in that, and I've really enjoyed reading through this particular standard. And then I've realised the other work he's doing with OWASP and the other ISO standard, which I think will be a bit of a game changer. I forget the name, I was just looking for it. I might buy it's only in draft form at the moment, so I might buy it this afternoon. Yeah, it's there too. ISO IEC DIS 27090, cybersecurity, artificial intelligence, guidance for addressing security threats and failures in AI systems, and that's in draft form, but I think I'm going to buy it anyway because I just like to be up to speed with these things and essentially get a head start so I can hit the ground running, because if that is essentially the AI version of 27001, then, you know, again, it's going to be a bit of a game changer. But I really like what Rob's doing, because with 5338 and this 27090, like, there's no conversations about these. It's quite shocking, really. All this AI governance talk on LinkedIn and stuff like that. And I'm thinking, well, what are you guys? What are you governing? Or are you just commenting? You get no disrespect, but like, I don't know. But shouts out to Rob van der Veer. Sorry, that's doing some amazing work, and I'll be purchasing that today in the next 10 minutes, I guess. Just more extraction pattern quality. The pattern now includes comprehensive coverage of all integrated standards, risk-based approach. Conclusion: the ISO 42119 AI testing framework pattern has been comprehensively enhanced with all critical information. 1,180 lines of detailed system prompt. The pattern is now the most comprehensive AI testing framework pattern available, if you say so. Integrating 12 ISO standards with full rigor and no necessary points omitted. I'll take that. It's for free, other than the cost of the standards, of course. I'll take that. You're saving me thousands of dollars. If you say it's the most comprehensive, I'll trust you. What else was there? Just for transparency, because, you know, things are not perfect, and I just want to be a bit clear here about those initial issues that I had. So this was another critical pattern, non-negotiable fix. The ISO pattern does not match the quality of the work in AIG patterns. The output quality was poor, inadequate, only reformats input, doesn't generate comprehensive test plan. And again, just a detailed list of what identified. Fix 1, add explicit generation directives. So this is the cursor rules that I created for sort of its brain and memory. So I've called it the Algorithim auditing journey, and it's just telling Cursor what it is. Essentially, it's a context file called Cursor Rules. You are Cursor AI, the technical partner for a 16-week intensive course. It's going to help me write Python code that generates audit evidence, create ISO compliant audit reports and findings, evidence management, organize audit artifacts systematically, help apply 15 ISO standards in practice, explain ML concepts at auditor level, understanding, not building. And what else? So it's got EU AI Act 1901, 5338, 22989, 2001, obviously, 23894, 42005, author 5259s, the bias, the software testing. Always include audit methodology and lifecycle stage. Excellent. Add relevant technical standards. Add governance layer. Add legal layer if applicable. Multi-standard citation. And then it just goes on. If you just look at the length of this, amazing. Detailed work. And you can see it's referring to certain parts of Amazon here, which I'll be showing in later videos as I work through it. So it's kind of like my focus is to essentially master SageMaker, and definitely how I can integrate these tools that I'm creating into SageMaker, AWS SageMaker, if you're not sure. But I was just like, okay, well, I'm going to do some SageMaker courses, definitely. Also, or should I say some training labs. And I think I'm also going to take the AI, what's it called again? I've actually bought the course this week. AI practitioner. That's it. The AWS AI practitioner course. So a lot of the sort of the basic stuff I know from doing the AIGP cert, and I'm already using Amazon SageMaker, Lambda, S3 buckets, stuff like that. But I still feel that I've got to fully understand what's going on, because yes, I'm using the AWS CLI to essentially create and automate things, but I need to know. So I thought, let me just create a course where I can at least have a conversation about what I'm doing, but then at the same time, I can still build scripts to analyze data and create reports based on my knowledge base. So that's one of the things here. It's like, yeah, it's asking me to complete reports. Am I going to do that part? Sometimes I will, sometimes I won't, because I'm trying to, essentially utilize the tools to their full capacity, which means, well, if I've got all the information there, I can create a script that extracts all the information and connects it to all these standards, and therefore gives me, a quality report. Then why ultimately do I need to go backwards? So at the same time, I'm gonna look through when it asks me to complete a report, as I'll show you in a minute. I'm gonna have a look at it and have a think about it. But ultimately, I can automate that as well. So it's a bit of both. But I'm hoping I'll get value out of at least knowing what a blank report looks like, and then just get that feeling of like, oh, wow, okay, this is what it would take to complete this. But moving forward, automation and AI governance engineering is the future. So I don't want to go too backwards here, but respectfully looking at where it comes from. So if I go to my curriculum, what have we got? Week 1 foundations, first audit, we've got a .py file, that's not what I want. First findings.md. So this is what's this? If you look here, perfect. I can see your evidence shows very high correlations between features. The most significant finding is the 0.96 correlation between petal length and petal width. Again, I don't know what this is, so I'm having to learn on the fly. This is extremely high and could indicate potential multicollinearity issues for modeling. Again, please keep in mind, I've created this to learn about machine learning, at least from auditing perspective. So I don't know what some of the vocabulary is yet, but as I go through and it presents new vocab to me and new ideas, I'll be sure to dig deeper into them. So anyway, it's created me a professional multi-standard audit. Let me give you a quick overview what this includes. Let's have a look, shall we? We don't need this. We can just have a look. Let's close that off a second. What it did was it gave me this sort of like, hypothetical situation. And the main aim is to map things to ISO 5338 AI system lifecycle. And it's identify which sections we need to look at. And the objective is practice identifying ISO 5338 lifecycle stages in real ML to build pattern recognition for audit work. So it was a credit risk assessment model used to approve a bank or reject a loan. So my task is to map the system to all 8 ISO lifecycle stages and identify audit verification points. So we started off with like the inception stage, which again, if we go, which is good about this tool or this curriculum, is that I can just go knowledge. And we're looking at 5. I need to organize these a bit better. Like you can see where we've had to update certain things. 5338, where are you? If anyone knows how to search quickly in cursor, let me know. I haven't checked yet. 5338. Where are you? You here? No, definitely not there. Am I going crazy? Right, there we go. So again, we're here looking at ISO 5338 lifecycle inception stage, and if I want to just verify things, I can just go into my knowledge base and open the documentation and just check myself. So that's what's really cool about this tool. I've got everything that I need. So yeah, that was it. I've got everything I need there if I want to check. And the aim of this activity was, it's telling you what activities you should see in the inception stage of 5338. What artifacts the business has provided, and then it was asking me to check off what I can see as evident from the artifacts. Now, I wasn't sure exactly what to do at first. Like, was there for example, here, these lines you can see highlighted. I was like, well, is this a test for me? Is there a right or wrong answer as such? I wasn't exactly sure. And then after a bit of back and forth with the chat window, it actually became more clear. So obviously I was going in a bit gung-ho at first, like ticking everything, and then the system would challenge me on, well, are you sure that's evident? Problem I found was that it was a bit too vague. The system should have given me more context for my learning experience or my learning journey, because I'm like, okay, there's some of the artifacts are vague and some of the activities are vague, and I was like, well, I can't see certain things in there. And then when I would put this to Claude, it would say, no, it's there, let me challenge you on this. And I'm like, well, where is it? So there was a bit of back and forth, and I've kind of asked the system to give a bit more context in future. Yeah, because it was a bit unclear. So that was a problem. But the point was, I got there in the end. I went through it a few times. I didn't give up, even though I wanted to, because it was just like, I could improve this. I know I could. But I just went with it anyway. I said, okay, cool. We've got what we've got. Let's dig in. And then you can see it just go through each part of the life cycle, the AI system life cycle relative to 5338. So we've got the data process stage, the modeling stage, what else? And you can see, because of the way I've got this set up, it shows below what the connection is to the ISO 42001, which again just is adding another layer to my learning journey. And I'll definitely have to revisit this activity just to start building up those patterns. Let's have a look. Deployment stage. And again, just constantly connecting to ISO 42001. So you just, as a consultant, you're just building those layers of knowledge. Over time, of course, this is not going to be an easy task at all. But again, I've set the bar quite high for myself. The retirement stage, I went in quite gung-ho on here. I was like, okay, they've mentioned this, they've mentioned that. But the mistake was, well, the system challenged me on saying, well, there was no mention that they're retiring it, they were in the building stage, so you shouldn't have ticked any of these. So that was an oversight. But again, it's just about learning what the system's trying to get from me, or how it's trying to teach me. So we're just figuring each other out at the moment. And then hopefully once I get into a rhythm, the deep learning can begin. And remember, if you're just listening, the whole purpose of this is to teach myself how to audit AI algorithms. That's the thing. So it's involving machine learning and just the deep end of the stuff. So again, here we got then the summary analysis of what this is showing. Stages with strong documentation: 7.2 data process, 7.3, 7.4, 7.6. So then next, it wanted me to create a diagram, but I just got this to do it itself. It's like, I'm not going to, again, we've got AI tools. I'm not going to sit there creating a diagram when it can do it for me. The main point is I'm here to learn. And yes, it's important to have a diagram mapping out 5338, and here it is. So you can see it's quite useful if you want something more visual. But I do have the documents there if I want to revisit them. But if you're visual, there you go. We've done the life cycle mapping, we've done the diagram, we've collected the audit evidence, and now we've got this report. Again, there was a Python script there which I created to extract all this evidence into a JSON. If you want to see the JSON, there it is for your auditing records. You can see lifecycle stage, data process, and all of the JSON information below. Outliers detected, clean, low, high. Excellent, full compliance, all features have 100% completeness, no missing values. All numeric features are properly typed, minimal outliers detected. Recommendations, data set is suitable for model training per ISO 5338 section 6.4.8, and then it's timestamp for auditing. Right then, so if we have a look then, so now at this point we're done, and it's say let's create your first professional multi-standard audit finding, and there we've got it, boom. So this is where we can have a look at the final piece. Excellent, I've created your first professional multi-standard audit finding. Let me give you a quick overview. So during automated data quality assessment of the Irish dataset training data, audit evidence revealed extremely high correlation between petal length and petal width, with 4 additional strong correlations detected across the feature set. Audit methodology. Again, this is the main point here, is like, how am I going to combine all of these standards to then learn, okay, if I want to start auditing AI systems or AI algorithms, so if I want to start auditing AI algorithms, what ISO documentations are going to back me up and support me with this? And it's just, I want to, through this 16-week program I've created, I want to just be able to just drill down. At first, I'm not going to remember everything, of course, but this is high level and would probably cost me thousands of dollars to buy a course with any similarity. So again, I'm not learning everything today, but I want to start building up those patterns as the weeks goes on, or months actually, 16 weeks. 16 weeks with no delays. So ISO 19011 2018 observation with recommended action. Audit principle applied, section 5.2.3, evidence-based approach. Evidence collected, automated correlation analysis using a Python pandas library with statistical validation. It's got my auditor's name there, the date. Evidence verification, qualitative statistical analysis with documented thresholds, correlation greater than 0.80, so it's flagged for review. Lifecycle context in regards to 5338. Section 6.4.8, AI data engineering process. Specific process, data validation and quality assessment prior to model training. Modeling and implementation, high multicollinearity can cause unstable coefficient estimates in linear models. Again, that's terminology I'm going to have to learn, but here it is. Inflated variance in predictions, I understand that. And difficulty in feature selection. Verification, feature importance analysis may be unreliable, making it difficult to verify which features truly drive model decisions. Validation, explainability and interpretability validation becomes challenging when features are highly redundant. Operation, ongoing monitoring of feature drift and model stability may produce misleading signals if correlated features drift. Standards violated or applicable. So the primary technical standard, AI identity. The purpose of the AI data engineering process is to obtain and prepare data for use in AI system development, operation and maintenance. Current state, the data validation performed and correlation analysis completed. High correlations detected in 5 feature pairs with petal length and width correlation at 0.9629 gap. No documented assessment of multicollinearity, impact on model interpretability, stability or compliance. Now, what's good about this, if I just sidestep 1 minute, the good thing about having this inside Cursor is that as I walk through this now, like say for example, I've just been mentioning that I don't understand what it's telling me. So where was I just reading? Here. So I can now, what I learned the other day is I can just do this. Oh, where am I? 39, and I can just Control L and explain this to me in simple layman's terms. What's the key vocabulary mean? And then within a few minutes, or seconds should I say, I can have this explained to me simplistically, and that's what's brilliant about using Cursor and this whole course thing. And it just came to me about 4 a.m. in the morning. I woke up and I was like, oh, I want to dig into this ML and algorithm auditing. Why don't I just build a course? And I just came back in here and just started tapping away at 4 o'clock. But this is helping me use Cursor in different ways as well, because obviously I'm just using it to code things out usually, but now it's more just like, okay, yeah, there's a small bit of coding to be done, but this sort of command line style of just highlighting that and then having the agent chat explain is brilliant. So let's have a look what it says for my simplistic ML data scientist, non-auditor brain. Right, so continuing where I left off. So now I've got like a simple explanation which helps me as a student understand, as you can see, this line here on line 38. Yes, I can sort of get an idea of what it's talking about, but I need to be certain. So here we go. I've simply connected it to the agent inside Cursor, and it's explaining it to me in a language which I can hopefully understand. So it's saying what the finding says: the audit discovered that the data analysis found a problem, high correlation between features, but nobody has documented what this problem means for the AI system or written down any rules about what correlation is too high. And now it's given me the key vocabulary explained: multicollinearity. Simple terms, when two pieces of information are almost the same thing measured in different ways. Example, imagine you're trying to predict if someone will like a movie and you use two features: how many minutes the movie is, how many hours the movie is. They are basically the same information. In the iris data set from your audit, petal length and petal width move together 96% of the time. If one is big, the other is big. They're telling you almost the same story. So model interpretability. Simple terms, can humans understand why the AI made a decision? I know that. So why multicollinearity hurts this? If a petal length and petal width are 96% the same, the AI might use one or the other or flip-flop between them randomly, and you can't get a clear answer about which feature actually matters. Okay, got it. Simple terms, does the AI behave consistently and predictably? If you train the AI on Monday, it might decide petal length is super important. Train the same AI on Tuesday with slightly different data, and now it thinks petal width is super important. That's unstable. The AI's opinion is wobbly. Explainability requirements. Legal regulatory rules say that you must be able to explain your AI's decisions. For example, GDPR and other places, if AI denies you something important, loan, job, healthcare, you have a legal right to know why. If the AI can't explain itself because of multicollinearity, the company is breaking the law. Define threshold, a written down rule that says if correlation is above X%, you need to do something about it. So the gap in one sentence, they checked the data and found the problem, but they never wrote down. So what does this problem actually mean for our AI? How high is too high? What should we do when we find out? It's like finding smoke in a building, but not having a fire safety plan. The smoke detector worked, the audit found the correlation, but nobody wrote down what to do about it. Yes, it makes sense. I don't need to apply, but thank you, Claude. So this is what's useful about this course that I've created for myself. This is not something I'm selling, obviously, and I'd encourage anyone who's sort of trying to get into AI governance I'd encourage you to do the same, because the expectations moving forward are that we have some technical understanding. So yes, is there any certification for what I'm doing? No, of course not. But I think given the need for experts that understand the regulatory landscape, the standards that can get us there, and the language that engineers, data scientists are using, there's very few people that are doing that or have those combined skill sets. So yes, there's no certification, there's no essentially reward for me at the end of the line for this, but hopefully I'll have the vocabulary, the understanding, knowing where to dig in, knowing how to speak to some degree the language used by these engineers and scientists, and hopefully that will give me some sort of head start or advantage and usefulness to companies where I know enough to talk their language. And that's the thing that was always bugging me. Moving forward, we're going to have to know both regulatory landscape and technical jargon, and I just couldn't I used to have these ideas about going in somewhere and just the technical team just looking at me with this look as if to say, who's this guy? What the hell does he know? And I can't accept that. So I'm creating my own program to help me at least know what I'm talking about and ask the right questions. I don't need a certification for this. As long as I've got the AIGP, I should be there for a reason, because I understand regulation and should I say, I've automated large parts of the regulatory framework and the standards that you need to get there. So I'm coming in with them. I'm adding them to my arsenal already from an efficiency and cost saving standpoint. But the language thing, that's where the gold is for me. That's what I really want to know. Anyway, let's have a look. So now we've gone on to data quality standards. We've jumped from 5338 to 5259. So principal data should be fit for purpose with appropriate diversity and representativeness. Current status or current state features pass completeness checks 100%, but exhibit high redundancy. The gap, feature redundancy not assessed as part of data quality framework. And then we jump to governance standard for 2001, Annex A 6.2.4 data management requirement. The organization shall establish, implement, and maintain processes for data management throughout the AI system lifecycle, including data quality assessment and validation, current implementation, partially implemented, basic data quality checks in place, but no multicolority assessment, as we just learnt from Claude there. Current implementation not assessed. Gap, high feature correlation directly impacts explainability, but it is not evaluated against transparency requirements. Now I understand that. Very simple. Technical evidence, Irish dataset analysis data, records analysed 150, features analysed 5, high correlation findings. What have we got? The feature pair, the petal width, target 0.9 point. Very strong positive high verification validation. Petal length 0.9.59. Very strong positive high correlation. Again, I'd need to just in fact, why don't I just do it live? So if I want to understand this a bit more, again, I'm just going to Control L. So I understand what you were talking about when you mentioned, what was the word again? What's the word again? I've already forgot it. Multicolority. So this is the high correlation findings. I can see the table there. Just explain this in more simplistic terms again. Oh. So think of this is a copycat detector for the iris flower measurements. The table shows which measurements are basically telling you the same information. So correlation number 0.0 to 1.0. Okay, simple terms, how much do these two measurements move together? 1.0 perfect copycats. We don't have any of them. 0.9 plus almost perfect copycats. We do have them. 0.8 strong copycats, and we do have two of them for sepal length. The two arrows just means compared to. Okay, got it. We're looking at the relationship between the two. So row 1 petal length 0.9629. Where's that gone? Okay. Yes, that one's highlighted already. High risk. If you measure how long a flower's petal is, you can predict how wide it is with 96% accuracy. They're almost the same information. Real world analogy, like measuring someone's height in inches versus centimeters, you're basically measuring the same thing twice. Why it's high risk, the AI might get confused about which one actually matters, making explanations unreliable. Row 2, petal width, 0.9565. High risk, what it means, just by looking at the width, you can guess the flower species correctly. Like knowing someone's shoe size tells you their height pretty accurately. Why it's high risk, if this measurement is so good at predicting the answer, we need to understand why, and if the other features are just noise. Another one, petal length. Again, similar. And then we've got the sepal ones, which are a bit less, and they're flagged as medium risk. Flowers with long sepals usually have long petals too. 87% correlation. Real world analogy, people with long arms often have long legs, related but not identical. And weight, medium risk, strong enough to cause some confusion but not as bad as the 9.6 copycats. Same problem. So imagine the big picture. Imagine you're trying to identify birds and your features are weight in pounds, weight in kilograms, etc. Features 1, 2, and 3 are all the same thing. You're not really using 4 different clues, you're using 2, but you measured weight 3 different ways. So that's what's happening with this iris flowers data set. Petal measurements are basically the same clue measured 2 ways. So instead of 4 independent clues, you really have maybe 2 to 3. And why this matters: for explaining decisions, your loan was denied because of your income, or maybe your salary, or was it your earnings? We're not sure which one because they're all the same thing measured differently. Got it. For the AI, the model gets confused about which measurement to trust, making it unreliable when you need to explain why. Got it. It clicks. So again, hopefully you can see the learning value of this tool here. If you're going to build your own, that is. But this is my own journey. Good luck, build your own. More information, I don't want to spend too much time on it, but we are wrapping up this video. Evidence location, so I've got the JSON saved, I've got the script saved, and the audit methodology was 19011, 2018, section 6.4.3, collecting and verifying information. Risk assessment, preview for ISO 23894, risk category data quality, feature redundancy, likelihood 5 out of 5, multicollinarities confirmed present in training data, impact 3 out of 5, moderate, affects interpretability and stability but not necessarily accuracy, risk score 15 out of 25 with a medium rating, risk justification, technical risk, model coefficients may be unstable, feature importance rankings may be unreliable, regulatory risk, if this system were used in regulated domains, credit, healthcare, hiring, inability to explain feature contributions could violate transparency requirements, operational risk, monitoring and drift detection may produce false signals if correlated features move together, reputational risk low, training data set only, not production system. Mitigating factors, this is a training learning exercise, not a production system. Iris dataset is a standard benchmark where high correlation is expected and documented. No real world decisions are being based on this model. Okay, let's have an impact analysis, technical impact on model development, ISO 5338, linear models, logistic regression will have inflated standard errors for correlated features. Feature selection algorithms may randomly choose one feature over another. Regularization L1, L2 may help, doesn't eliminate interpretability issues. On model verification, feature importance analysis, SHAP, permutation importance will show unstable rankings. Let's have a look what this means. So again, explain in simple terms. So what feature importance analysis means? Simple terms. Asking the AI which measurements mattered most in your decision. Real world analogy after a job interview. Asking what factors made you hire me. The interview might say 40% your experience, 30% your education. That's a ranking of which factors are most important. What SHAP and permutation importance mean? That's what I wanted to know. These are just 2 different methods for asking the AI what mattered most, okay? Think of them like 2 different ways to grade a test. SHAP is like grading with partial credit. Permutation importance is like grading pass or fail. Okay. So SHAP is like grading with partial credit. Yes. Permutation importance is like pass or fail, black or. They're both trying to figure out the same thing. Which features drove the decision? What unstable rankings mean? Simple terms. Every time you ask, you get a different answer. With the flower data, model says petal length is most important, petal width second, sepal length, etc. To Tuesday's AI says petal width, petal length. Notice the problem, petal length and petal width keep swapping. Yeah, absolutely. So why this happens, the multicollinarity connection. Remember how petal length and petal width are 96% copycats. AI can't tell them apart, so it randomly picks one as more important. You have to rank them further. They're basically the same. Your ranking, okay. Why unstable rankings are a problem. For explanation, Monday you were denied a loan because your income was the number one factor. Tuesday you were denied because your debt was the number one factor. Reality, the AI doesn't actually know, it's just guessing. For trust, if the AI's explanation changes every time, would you trust it? Would a regulator accept it? For debugging, let me check which features are broken. Today it's petal length, yesterday it was petal width, tomorrow it might be sepal length. Okay, so when features are copycats, multicollinarity. Okay, I've got that now. It's in there. Thank you. Which one mattered most? Is like asking someone to rank identical twins. The answer will be random and keep changing. Yes, it does clarify. On with the show. Let me read it one more time. Feature importance analysis, SHAP permutation will show unstable rankings. Yes. Difficult to got it. Explainability validation becomes challenging. Again, why did petal length matter but not petal width? Got it. Business impact. If this were a real world scenario, regulatory compliance, difficult meeting right to explanation requirements as per GDPR Article 22 and EU AI Act transparency obligations. Businesses may lose confidence if model explanations are inconsistent or unstable. It's harder to document clear rationale for decisions, increasing your audit risk. Model maintenance, feature drift monitoring becomes less reliable. And for this training exercise, learning opportunity, excellent case study for understanding multicollinarity in real data. Portfolio value demonstrates ability to identify and document data quality issues per ISO standard. Recommendations. Document the high correlation findings in the data quality report and assess whether it impacts intended use case. And it tells you who the responsibility is on, the data engineering team, the ML engineer. Data quality report updated with correlation analysis section, decision documented. Yeah, sorry if this is a bit boring, guys. I'm just trying to show you like the sort of the value of this course, especially if it's something as an AI auditor or consultant you want to sort of develop yourself. Hopefully you can get some information from this of how to do it and just see the value in it and save yourself a couple of $1,000s in the meantime. Let's have a look. If proceeding to modeling, select algorithms robust to multicollinarity, tree-based models, neural networks, or apply dimensionality reduction. Okay, I want to know more about that there because it's kind of... That sounds important. Let's have a look. Important to know anyway. Explain this to me in simplistic terms. So the problem we solve. Remember petal length? Yes, we know that. This line is saying here are 2 ways to deal with it. Good. Pick algorithms that don't care about copycats. Okay, here's a learning experience. Select algorithms robust to multicollinarity, tree-based models and neural networks. What robust to collinarity means? Simple terms. Some AI methods get confused by copycats, others don't care. It's tree-based. What are they? Decision trees, I know about them. Random forests, I know about them. XGBoost, I've been using that, but I don't know what it is. It's in my SageMaker training examples, and I've always saw that, and I'm like, what does it mean? Now I can find out. Some simple analogy, like playing 20 questions to guess something. Is the petal longer than 3 centimeters? Yes. Is it wider than 1.5? No. Why they handle copycats well? The tree just picks one feature at each split and ignores the other. It's like saying, I only need to measure height in inches, I'll ignore centimeters. The tree naturally avoids using both copycats. Neural networks. Okay, I know what neural networks are. Why they handle copycats well. They're so flexible and complex that they can figure out, oh, these 2 features are basically the same and adjust their internal math automatically. Solution to remove the duplicate information or apply dimensionality reduction. This is the opposite approach. Instead of picking a smart AI, clean up the data first. Method A, this is what I want to know. Principal component analysis. Simple terms, combine the copycats into one new super feature. Principal component analysis, okay. Real world, you have height in inches, height in centimeters. PCA says, let's just create one new measurement called height. It captures all three. Now you have one feature instead of three redundant ones. Applied to flowers, you have petal length 96, petal width 96. PCA creates petal size. Okay, one feature that captures both. Problem solved. Cool, got it. PCA. Method 2, pick one and throw away the other. That makes sense. Petal length, petal width. It says keep petal length. Got it. So if proceeding to, so this again, it's just breaking it down into English terms, but I've got that now. If proceeding to modeling, select algorithms robust to multicollinearity, tree-based models, neural networks, or applied dimensionality reduction, PCA. Feature selection. Plain English, before you build your AI, pick one of these strategies. Strategy A, use a type of AI that's smart enough to handle copycat features, or clean up your data by either combining the copycats or just deleting. Got it, I like that. That makes sense, yes. Right, and let's see if I can start wrapping this up. Just more solutions. But again, I'm doing this for the video purposes to document my journey, but obviously I will go through this in my own time and just make sure I understand what all of this means, and then I'll be adding it to, again you can see here it's saying this audit file is created for part 1 of the 16-week algorithm auditing course. And then what I'm going to do is at the end of this, once I've asked it all these questions, I'm gonna then ask, I'm not going to do it myself, why should I? We live in an age of automation. I'm going to get the chat to populate this note section for me. So the key takeaways, the questions I've asked, etc. Get it to add those things in there for me. I don't know if I need all of this. This is quite detailed, but that's what I'm going to get it to do. Oops, sorry, I'm going to get it to just populate all of this for me itself. So yeah, that's sort of week 1 of this course I wanted to show you in this learning journey. It's going to develop a lot more. There's lots of different activities to it. Like the main purpose is to essentially help me understand how what I'm doing with my tools in Amazon or AWS SageMaker, what it is. So for example, if I just look through there and I see the point about, what was it again? Yeah, this XG boost. Again, when I'm doing these demos in AWS and I'm creating these sort of fake or hypothetical situations, it mentions that, for example, that this healthcare business or finance business has used an XG boost sort of model, and I've never understood what it is. I'm just like, okay, well, I'll just accept what it is, but I need to know those things. I want to know those things, should I say. So this is what I'll be extracting and adding to the notes file of this. So anyway, thank you for checking in and watching this journey. You know, again, if there's any feedback, please do comment or send me an inbox. Or if you'd like to know how to build your own, I can share some of the steps I took as well. Yeah, I'm just learning. I'm trying to learn and document this learning journey. Remembering I don't have any experience in IT. I don't have any experience in machine learning other than what I've studied in AIGP. I'm not a data scientist, I'm not a machine learning engineer, I'm not a coder, but I'm leveraging the tools available these days to upskill myself. And you know, we've never been in such a beautiful place where if you are hungry for knowledge or hungry to learn, the tools are there now. It's just crazy. So I am going to learn or teach myself how to talk the language of the machine learning engineers, DevOps, data scientists. That's what I'm coming for. I want to know their language from an auditing perspective, and that is the challenge I'm setting myself, to make sure that as I step in, as this industry develops, that I can offer value and not just come in there with a spreadsheet and not know what the hell I'm talking about. So again, thanks for watching, guys. This is part 1. There's going to be many more coming. So thank you for joining in and watching AI Governance Weekly with myself, Gavin, and I'll see you again next time.